All right, so I think this is recorded. Let's take a look at problem number 8. We have a radical equation. We want to solve it. We know that we need to make sure that the radical term is by itself. And to get rid of the square root, we square both sides. Well, we square it, and then to balance the equation, we square both sides. So if we square our radical, the radical will go away, but to balance the equation, we need to square the other side. So the resulting equation is a quadratic. And we know that quadratics have two solutions. Now, the solutions to a quadratic equation are never extraneous, but we started with a radical equation, and the solutions to radical equations may be extraneous. So let's get this equation in standard form. I prefer to have a leading coefficient be positive, so I'm going to move these two terms to the left-hand side. I'm going to subtract 11p, so it'll cancel from that, from the right-hand side, and so then I'll write minus 11p there. I always remember that if a term changes sides of the equation, it changes sign. That was plus 11p, and now it's minus 11p because it's on the other side of the equation. If I add 24, it'll cancel with that term, so that minus 24 will become plus 24 if you move it to the other side. So now with the leading coefficient of 1, this is pretty easy to factor. We come up with two numbers that when multiplied together give us positive 24, but when added are negative 11. And minus 3 and minus 8 will do the trick, because negative 3 times a negative 8 is positive 24, and negative 3 plus a negative 8 is negative 11. So if these two expressions have a product of 0, then one of these numbers has to be 0. So either p is equal to 3 or p is equal to 8. And those are both solutions to this quadratic equation. However, they may not both be solutions to our original equation. We're going to have to plug it in to check. In the original equation, p is on the left here. We're going to replace p with 3. And the big question is, when we do this arithmetic on the right-hand side, are we going to get 3? So underneath the radical, we have negative 24 plus 11 times p, but we're replacing p with 3. So negative 24 plus 33 is 9. And the principal square root of 9 is 3. So this does satisfy that original equation, and 3 is in our solution set. Now, what about 8? If we replace the left-hand side, if we replace p with 8, on the right-hand side, when we do our arithmetic, are we going to get 8? Well, we've got negative 24 plus 11 times p, but this time we think that p will be 8. So is negative 24 plus 88 equal to 64? I believe it is, but let's double check. Yeah, it's 64. And I know the principal square root of 64 is 8. So this is satisfied. All right, so both of these are in my solution set. They both checked on the original equation. All right, well, I hope that helped. Don't be afraid to ask questions, and I'll talk to you later. Bye.